Hello and welcome to part 3 of the chapter 3 C++ examples. We're starting with example 3-21, and in this example we'll show you how to use the cn.get function that gets a single character. And in this example you can see how you can use this to prompt the user to press enter to continue. So we'll go ahead and run this. Let's see that we pause the program, press enter to continue. Again, we keep pressing enter until we're done. Okay, and then an example 3-22. Here again, we have a number. We prompt the user to enter a number and then enter a character. So we'll go ahead and run this. And you see it didn't pause for us here. It just went all the way through. And the reason for that is when you enter a number, when you hit the enter key, that puts a new line character, and that stays in the buffer. So when cn.get gets that new line, it gets that new line, so the console never stops to prompt for a new line because it consumes it right away. It doesn't need to prompt. So the way around that is every time you do a cin, it's always a good idea to have a cin ignore right after that, so it ignores the enter key or the new line character. So again, if we go ahead and run this, now when I enter the number and hit enter, it pauses for the character. So now I can put in a character and everything works properly. Now for example 3-24, in this example we're displaying two things. One is we're using the square root function. Again, that's coming from the CMath library, as well as the power function. Okay, so here we're calculating the hypotenuse from the length of two sides of a triangle. So we'll go ahead and run this. So we'll say 3, 4, and the length of the hypotenuse is 5. And you can see by set precision 2, oh, well, that was a bad example. We should probably use something like this. And it gives an hypotenuse of 5.2. Oh, because we set the precision to 2. Example 3-25, this shows the use of a random number generator. So here we're going to seed our random number generator with the system time, and that'll sran seeds the random number generator. Then ran generates the random number. So we go ahead and run this, and you see it does create random numbers, but they're kind of these huge numbers. So the question is, how do you control the range of random numbers if you want to give it a particular range? And that's what we're going to learn in example 3-26. So here we're still seeding the random number generator, but now we use the modulus operator, and that kind of controls our range. So we're always going to divide it by whatever the range is of numbers we want. So here we want, if we're simulating rolling dice, we want to only generate random numbers between 1 and 6. So we need to take the maximum value, subtract the minimum value, add 1. So in this case, you're going to be doing a modulus of 6. So your valid values are going to be 0 through 5, because modulus takes the remainder. So if you're dividing by 6, you're going to get a number, or a remainder in the range of 0 through 5. So you want to add 1 to that, which is 1 through 6. And now if we go ahead and run this, you see we're rolling the dice, and then we're going to keep rolling it to see if we're actually getting random numbers here. Yep, so now we're getting different numbers. Yep, we got both different numbers. Okay, 3-27. Again, here we have a whole bunch of, we're calculating the average number here. So again, and finally for 3-28, this is the case study program that we went through at the end of the chapter. So I'm going to go ahead and just run this. The key thing here is really calculating the cost per cubic foot to build a crate. And so basically the cost to build is 23 cents per cubic feet, and you charge the customer 50 cents per cubic feet. So that gives you a profit of about 27 cents, I believe, per cubic foot. So this program will help calculate your cost and your profit on each crate that you build. So here we're going to enter the dimensions of the crate. So we got 10 by 20 by 30. Again, we got a 6,000 cubic feet crate. Cost $1,380 to build. We charge a customer $3,000, so we net a profit of $1,620.